Section E, there are 3 questions of 5 marks each, 50 total marks 15. Question number 31 first. A. Write 2 limitations of Ohm's law. Plot their I-V characteristics. B part. A heating element connected across a battery of 100 volt having an internal resistance of 1 ohm draws an initial current of 10 ampere at room temperature 20 degrees Celsius, which settles after a few seconds to a steady value. What is the power consumed by battery itself after the steady temperature of 320 degrees Celsius is attained? Temperature coefficient of the resistance averaged over the temperature range involved is 3.7 into 10 raised to power minus 4 per degree Celsius. So here the limitations of Ohm's law are, first thing is the Ohm's law is applicable for conductors and it is applicable only when the physical conditions like temperature of the conductor are kept constant. Third, although you have to write only 2, but for your knowledge, I am giving you more. This Ohm's law is not applicable to semiconductor devices like semiconductor diodes, transistors. This Ohm's law is also not applicable to non-linear circuits like thermistor, thyristors. The graph for semiconductor devices is like this. This is the V and this is the I. In case of if the temperature in case of doing experiment of Ohm's law, if the key is kept connected for a long time, then you might have seen that the graph goes like this instead of a straight line. So here this is not applicable. This is I and this is V. In case of thyristors, this is V and this is I. The graph goes like this. Here it goes like this and then like this. So these are the variations in these different situations or different devices. Now, this is the question number 31, first part. First B part. Here we are given a heating element connected across a battery of 100 volt. So V equals to 100 volt. Having internal resistance of R equals to 1 ohm. Draws an initial current I equals to 10 ampere. And that time the temperature T1 equals to 20 degrees Celsius, and which settles after a steady value, that is of T2 is 320 degrees Celsius, and the alpha, that is temperature coefficient of resistance, is 3.7 into 10 raised to power minus 4 per degree Celsius. So whenever you are going to solve numerical problem, First out, list out the data, and after listing the data, you will get the idea which formula is going to be applied here. We know that I equals to E by R plus capital R, the load resistance. Here this V is can be taken as the EMF. So here the current is 10 ampere, and this way the E is 100 volt upon R is 1 plus capital R you can find. So this capital R equals to 100 upon 10 minus 1, that is 9 ohm. So this is the temperature at 20 degrees Celsius. R20 you can say is 9 ohm. I equals क्या होता है E upon R plus R. Small r is the internal resistance and this is the load resistance. अगर हम इसको देखें ऐसे तो ये इस तरह से है, तो यहाँ इंटरनल रेजिस्टेंस है, यहाँ पर आपका E है और यहाँ पर कैपिटल R है, तो जो करंट आपका आएगा दैट विल बी E अपॉन R प्लस R. ये सीरीज में आ जाएंगे, तो इस तरह से आएगा. इस तरह से हमने क्या किया, ये R निकाल लिया एंड दिस इज द R एट 20 डिग्री सेल्सियस. नाउ यू कैन हैव दिस R एट 320 डिग्री सेल्सियस एज equals to R20 into 1 plus alpha, and the difference is 320 minus 20 is that is 300. So this way we can calculate R20 is 9, this is 1 plus 3.7 into 10 to the power minus 4 into 300, that comes to be 9 into 1 plus 3 7 are 21 and 3 3 are 9 and 2 11 and minus 2 and 1 minus 3. So minus 3 means 1 2 3. So 0.11. So this will be 9 into 1.111, that is 9.999 ohms. You can take it as 10 ohm also approximately, but for exact calculation we'll do with this. Now we have to find the what is the power consumed by the battery itself. The power consumed by battery. Now the power dissipated by the battery itself, that means due to the internal resistance, that will be I dash square into R. And how will be the I dash? I dash will be equal to again 100 upon R plus R320. So that is 100 upon 1 plus 9.999, or you can take it 10, so that will become 11, but we will do it by 100 upon 10.999. Now this power will be equals to 100 upon 10.999 square into 1, and after calculation this comes to be 82.66 वॉट से. एक बार फिर से देखेंगे, यहां पहले हम टोटल आई निकालेंगे. आई की वैल्यू है E अपॉन R प्लस R. आई दिया हुआ है 10, यहाँ 100 है, इससे हमारा R निकल जाएगा जो 20 डिग्री सेल्सियस पे है, तो उसकी वैल्यू आ गई 9 ओम. फिर फॉर्मूला होता है RT इक्वल्स टू R नॉट इंटू 1 प्लस अल्फा डेल्टा T, टेम्परेचर रेजिस्टेंस डिपेंडेंट. तो ये R320 will equal to R20 into 1 plus alpha, और टेम्परेचर डिफरेंस हो गया 300. उससे हमने निकाले 9 into 1 plus 3.7 into minus 4 into 300, that comes to be 9.99 ohm, which can be taken as 10 also, no issue, but accurately करिए. फिर उन्होंने पूछा है कि power dissipated by or power consumed by the battery itself. The battery itself means due to the internal resistance. So that will be P equals to I dash square R. Why I dash? Because now the temperature, the resistance has changed, so the current will also not be 10 ampere, but it will be something different. So that is 100 upon R plus 320, that is 1 plus 9.99, so it will be 10.9, that is almost 11. so that current will decrease. So when current will decrease, so power consumption will be 100 upon 10.99 whole square into 1. After calculating this, we will get 82.66 watt. Thirty-first or part, second A. Using Kirchoff's laws, obtain the equation of balanced state in Wheatstone bridge. And the B part is a wire of uniform cross section and resistance of 10 ohm is bent in the shape of circle as shown in figure. The resistance of 10 ohm is connected to diametrically opposite ends C and D. A battery of EMF 8 volt is connected between A and B. Determine the current flowing through the arm AD. So first A part, Wheatstone bridge conditions. So here we'll have this. So here is the battery. This is the point A and this is C. This is the B point and this is the D point, and here is connected the galvanometer. This arm has the resistance P, this has the Q, this has the R and this is the S. So let us say here is the current I. So here current will be, let us say I1. So according to junction rule, here it will be I minus I1. If here the current is IG, again according to junction rule, here it will be I1 minus IG. And here it will be the sum of these two currents according to junction rule. So it will be I minus I1. So first A part, Wheatstone bridge conditions. So here we'll have this. So here is the battery. This is the point A and this is C. This is the B point and this is the D point, and here is connected the galvanometer. This arm has the resistance P, this has the Q, this has the R and this is the S. So let us say here is the current I. So here current will be, let us say I1. So according to junction rule, here it will be I minus I1. If here the current is IG, again according to junction rule, here it will be I1 minus IG. And here it will be the sum of these two currents according to junction rule. So it will be I minus I1 plus IG. So applying mesh rule in the mesh 1, we have EMF is 0, that is I1P plus Ig into G. This is G is the resistance of the galvanometer, let us say, minus I minus I1 into R. So here this minus IR will come here, so it will IR will become I1 take common P plus R plus Ig into G, equation number 1. Similarly, applying this in mesh number 2, and if we just take it like this, so here we have again mesh 2, 0 equals to I1 minus Ig into Q minus I minus I1 plus Ig into S minus Ig into G. So this minus I into S will come here, that will become Is. Taking I1 common, we get Q plus this minus will become plus, then Q plus S, and then minus common, this will be Ig common. So we have Q plus S. This is going to become plus minus minus and then this plus G. So this way here we have equation number 2. एक बार फिर से देख लीजिए, इस मैथ में हमने देखा कि यहाँ पर EMF 0 है, तो 0 इज इक्वल टू I1P प्लस IgG, एंड इसमें अपोजिट चल रहा है इसलिए माइनस हो जाएगा I माइनस I1R. इसको ब्रैकेट खोलेंगे तो माइनस IR प्लस I1R आएगा, तो माइनस IR को हम यहाँ तक ले आएंगे और here आएगा I1P प्लस I1R, तो I1 कॉमन ले लिया, P प्लस R प्लस Ig इंटू G, इक्वेशन नंबर 1. सिमिलरली इस मैथ में जैसे हमने अप्लाई किया तो यहाँ भी EMF 0 है, तो 0 इज इक्वल टू I1 माइनस Ig इंटू Q. अब इसके अगेंस्ट आ रहे तो माइनस I माइनस I1 प्लस Ig है ये इंटू S, और यहाँ पर अगेंस्ट आ रहे हैं तो माइनस Ig इंटू G. अब यहाँ ब्रैकेट खोलेंगे तो ये होगा माइनस IS, तो उसको इधर ले आए हम, पॉजिटिव जाएगा. और यहाँ देखिए I1Q पॉजिटिव है, ये माइनस माइनस क्या होगा प्लस हो जाएगा I1S, तो इन दोनों को कॉमन ले लिया I1 में, तो Q प्लस S. और ये देखिए माइनस IgQ आएगा, माइनस IgS आएगा, माइनस Ig इंटू G आएगा, इसे माइनस Ig कॉमन लिया तो Q प्लस S प्लस G, तो इक्वेशन नंबर 2. नाउ इन equilibrium condition or bridge condition. Bridge condition means when no current will flow from B to D. So that time Ig will be 0. So substituting the value of Ig as 0 in equation number 1 and 2, then equation 1 and 2 become IR equals to I1 P plus R, and this is 3, and equation number 2 will become IS equals to I1 Q plus S, equation number 4. Now dividing 3 by 4, we get R upon S is equal to P plus R अपॉन Q प्लस S. यहाँ पर Ig की वैल्यू 0 हो जाएगी तो ये केवल इतना बच जाएगा और यहाँ ये इतना बच जाएगा. अब इन दोनों को हमने डिवाइड किया तो I से I यहाँ कट जाएगा, तो यहाँ बचेगा R बाय S, और यहाँ I1 से I1 कटेगा तो बचेगा P प्लस R अपॉन Q प्लस S. अब क्रॉस मल्टीप्लाई करते हैं तो क्या मिलेगा, RQ प्लस RS इज इक्वल टू SP प्लस SR. ये SR और RS एक ही चीज है, तो देयरफॉर R by S, or you just simply write RQ is equals to SP. यहां से अगर हम देखें आगे तो we'll get P by Q. इस Q को नीचे ले जाएं, इक्वल टू कितना हो जाएगा R by S. So this is the Wheatstone bridge condition which is asked. तो ये सिंपल है बहुत. किरचॉफ्स लॉस यूज करने पहले जंक्शन रूल यूज करिए और कोशिश करिए मिनिमम नंबर में. बच्चे क्या करते हैं, यहाँ I1 ले लें, यहाँ I2 ले लेते हैं, यहाँ फिर Ig हो गया, फिर वो और नया, उससे फिर कॉम्प्लिकेटेड हो जाता है. तो कीप द लीस्ट नंबर ऑफ वेरिएबल्स यूजिंग जंक्शन रूल. Now 31st second B part. Here we have the circuit diagram given to us. This is the circle and it is a wire of uniform cross section resistance of 12 ohm is bent in the shape of the circle as shown in figure. A resistance of 10 ohm is connected to diametrically opposite ends of C and D. यहाँ पर एक रेजिस्टेंस कनेक्टेड है C और D के अक्रॉस which is 10 ohm, and here this A and B are connected with a battery of 8 volt. Battery of 8 volt. This is a point O. And the resistance of the whole wire is 12 ohm. The resistance is connected of 10 ohm. And these 2 points are connected here and here, A and O and O and B. This point A and D are making angle 60 degree O. It is given in the diagram. Again, this D and B are also making at angle 60 degree at O. That means this is angle 120. So this will be also 120 because it is the diameter. So this is 120, this is 120. So here, this is 1/3 part of the circle, this is 1/3 part of the circle, and this is 1/3 part of the circle. So it is 1/3 of the 12, that is a 4 ohm. This is 1/3 of 12, that is 4 ohm. And this total is 4 ohm. That means here it will be 2 ohm each. So here we can see the Wheatstone bridge, just like this. Just see. This is 10 ohm. This is 4 ohm. This is 4 ohm. This is 2 ohm. This is 2 ohm. This is A, this is B, and this is C and D, and this is 8 volt. So this upon this is equal to same as this upon this. So we can neglect this resistance 10 ohm, and now the exact circuit will become like this. So this will be 4 ohm. This will be 4 ohm, this will be 2 ohm, this will be 2 ohm, and here it is 8 volt. फिर से देखिए, ये 4 ओम है, ये 4 ओम है, तो ये 4 हमने लगा दिया, यहाँ 4 हो गया, C पॉइंट है, C से D पॉइंट हमने यहाँ बनाया, यहाँ 10 ओम का रेजिस्टेंस लगा हुआ है, A से D पे जो है 2 ओम का है, और D से B के 2 ओम का है. इसमें आप रेजिस्टेंस ऐसे शो कर सकते हैं, कोई इश्यू नहीं है, और वायर लिखा है, वायर था, इसे मैंने वायर ही बना दिया. अब Wheatstone bridge की कंडीशन बन गई, तो this by this equal to this by this, तो 4 by 4 is 1 and 2 by 2 is 1. तो इसलिए क्या है? It is satisfying the Wheatstone bridge condition. So this no current will flow this resistor 10 ohm. So we can neglect it, and the equivalent circuit will become 4 ohm, 4 ohm here, 2 ohm, 2 ohm here. So these two 4 ohm are in series, और ये बैटरी लगाई दी आपने, तो ये सीरीज में कितना हो जाएगा? यहाँ हो जाएगा 8 ओम, और यहाँ क्या हो जाएगा 2 ओम, और यहाँ ये 8 ओम का 8 वोल्ट का बैटरी लगा हुआ है, तो 8 and 4. So what will be the current through AD? We are interested to find the current in AD. So इस पाथ में हमारा कितना करंट जाएगा, that we have to find. तो that current will be, since they are parallel में है, तो इसलिए सीधे parallel डायरेक्ट निकाल सकते हैं. So the current, this is suppose I1 and this is suppose I2. So we are required to find out the value of I1, that is 8 by 4, that is 2 ampere. तो इसमें जो करंट आएगा वो 2 एम्पियर आएगा. So correct answer is 2 ampere.